Hey there, welcome back to another video. Today we're going to talk about specialized tooling that you need to work on, service, and overhaul Ford AOD-E 470-75 transmissions. So these transmissions can be very finicky, especially the AOD, and they do require some specialized tooling in order to work on them, at least do it in a way that's efficient and low risk. So we'll go over those tools here that we have on the bench. And you'll have seen, if you watch the AOD reassembly series that I have out there on the channel, you will have seen me use these at various junctures, except for the bushings. I didn't actually film that, just time did not allow for it. But the next AOD I get in, I'll go ahead and film the bushing removal and reinstallation. But I will start with the bushings, and I'm just going to point to the blind hole puller set that I have there at the back of the bench. And if you're going to do transmissions, to any scale whatsoever beyond maybe once ever in your life, I would strongly recommend you invest in a blind hole puller set like the kind you see there. They're collet style, they work with a slide hammer, and they pull bushings out very, very, very quickly. So this set I purchased about 5 or 6 years ago or so on eBay for about 50 bucks, and I've used it on countless transmissions. Prior to that, I was using a combination of chisels and bushing drivers, where I was able to remove the bushing using the driver, because you have access. But many parts and components and transmissions, and especially some of the Ford stuff, you can't just simply use a bushing driver. You have to pull it out, at least in a way that's so it's safe and that you don't risk damaging the component. So again, strongly recommend you invest in a bushing puller set, especially if you're going to rebuild transmissions more than just once in a blue moon. Okay, I'm going to shift the camera over to the left a little bit, and we're going to continue bushings and focus on the installation. So I have all the bushings that I used to install whatever bushings that had to be installed in the AOD that I built and I show on YouTube. This particular set here is an AOD 470-75W specific set. It's purchased and available on eBay. The vendor, I believe, is a company called Streetside Tools, and there's them and I think one or two other vendors that are either related to them. In other words, it's a subsidiary, they have a relationship, or they're just very similar and they all happen to sell transmission tools. But this particular vendor, I believe, is out of Texas, San Antonio or Dallas or somewhere in there. And they make available for some transmissions a bushing driver set that is specific for that unit, and it will cover all the different bushings. And many of these bushing drivers are designed to install the bushing to depth exactly how it needs to be. Okay, the one additional bushing driver that you see in the back here is not from this kit. This is an OTC tool, and this driver is for the rear case bushing. So the tool number is T80L77110-A, and it says case rear bushing REPL, whatever that means. So essentially what it does is it stabilizes the bushing here, and then it drives it to the perfect depth. So if you don't have this tool, you do run the risk of breaking the bushing because it's not stable, and maybe you hit it off axis or not in the center with your long drift punch, or whatever the case may be, whatever you're using, and the bushing gets cockeyed in the bore. And if it's at the wrong distance in terms of its travel and it's cockeyed enough, you're going to break the bushing. So the other risk is that you somehow damage the case. This driver completely eliminates those concerns. So if you're going to even work on just one, your own, say, or a friend's or family member's AOD transmission, you're going to want to invest in that tool. I found it on eBay, just like I find all these other tools. 99.9% of the transmission specialty tools that I buy, I find on eBay, and I just punch in the tool number or the catalog number, and you know, if it's available, you know, it'll show up. So some tools are a lot more expensive than others. Sometimes you can get lucky and get a deal. This one I think was 60 bucks, you know, around there, $65 shipped, something like that. It was not that expensive. All right, so the other tool that you see immediately to the left of it is going to be OTC 1177. That's a slide hammer. Okay, now this is not the OTC slide hammer and puller that the ATSG manual lists as the kind of, you know, quote unquote official dealership service tool for that rear bushing. But what this puller and slide hammer combo will do is yank out that rear bushing for you, and it makes quick work of it. So there's one thing you need to know if you're going to buy this tool. It's I want to say $90 shipped on Amazon, and it's also available on eBay. You have to grind flat the base of each leg here, okay, by the feet. Okay, you gotta grind the base of the foot flat like you see it here, because if you don't, you won't be able to get in behind the bushing. It's kind of too wide. So other than that, no mods are needed. So all you do is install it, and you want to get the tops of the legs such that they're all situated underneath this adjusting screw, okay? Because what this does is it sets and adjusts the width of spread for the legs. And then once it's wide enough and you have a firm purchase underneath that bushing, 3 points of contact, then 4 or 5 smacks and that bushing comes right out. And there's very, very little risk to the case. You know, no chance of you damaging it, gouging, you know, chunks of it out or whatever. It makes quick work of it for you. So 90 bucks, modify the legs like you saw, and buy that OTC installation tool, and the rear case bushing, you know, will no longer be a concern. You know, a lot of folks will not replace it, and you know, like all bushings in this transmission, they have to be replaced. They're heavily worn. But the two-wheel drive variants, the bushing is more worn than it is with the 4x4 units. Reason for that is simple. That bushing takes the much more of the load and stress when interfaced directly with a slip yoke and a drive shaft than it does when the transmission is mated to a transfer case. Transfer case obviously a lot more stable. So you know, there's less wear and stresses being imparted onto the bushing from the transfer case. All right, so that covers bushings. The last thing I'll mention is you will need to have some sort of thin chisel like this. A thin, sharp chisel. So I use this, and it took me about 15 minutes to cut the bushing in the direct drum enough to where I can extract it. And this particular transmission that's featured on the channel, you know, in the rebuild series and the teardowns, the same transmission, was a nightmare when it comes to bushing extraction. It was just a pain in the ass. So have a sharp chisel. You're probably going to need it, especially for that direct drum bushing, because it would not come out by just simply using the slide hammer and the, you know, the puller that you see there as part of that kit. I don't know why. You know, whoever rebuilt that thing prior to me didn't replace any of the bushings. And I guess on one, you know, from one point of view, I guess I understand why. Though it's an absolute non-starter when it comes to properly overhauling these units. You have to replace bushings. So I understand why, you know, you don't want to do it, or he didn't want to do it. But you know, regardless, he should have outsourced the work if need be. And you know, if you don't want to spend all this kind of money on these tools, you know, just take all your parts, including your case, to a transmission shop, and you know, along with your bushing kit, and they will R&R bushings for you. Now, how much they're going to charge you for these specific units, or you know, it's going to be more than say a 4L60E or you know a 727 or something like that, because these are very labor intensive when it comes to bushing removal and replacement. So just, you know, kind of know that, and you know, prepare for it in your budget up front if you're going to outsource it. All right, the next set of tools I'm going to talk about are in the front of the table here, so let me reposition the camera real quick. Okay, so these first two tools I use to install the servo assembly, so both the low reverse and the overdrive servo piston. And then this tool I use to engage the piston, the apply pin with the pin apply point on the band. Alright, so this is a General Motors tool. It's some sort of press tooling or cup or something. I think it's actually for ball joints to wood vehicles. I have no idea. But the number is J35739-3. And for the overdrive servo, I use it in conjunction with this thing. Alright, so if you're familiar at all with either 4L60Es or 700R4s, or just watched other videos of mine on those transmissions on the channel or other channels, you'll know that this is a D10 roller. Okay, so transmission shops, junkyards, the internet, eBay, you can probably pick one up at the junkyard literally for nothing. A transmission shop will sell you one for a couple of bucks, or maybe they'll just give it to you as part of a larger order when you go buy all your parts and supplies. But what you want to use this thing for is to engage and position the band so that you can install your overdrive servo piston and not have to worry about having a neutral condition in fourth because your piston pin is not actually on the apply point on that band. So the only thing holding the band in position so that the servo can apply it is the servo itself, the tip of the pin. So if you need to either withdraw the servo to either replace it or to service it, maybe seals or sealing rings have worn out and you're trying to do an in-vehicle repair, if you don't position this thing in a certain spot, which I'll describe in a second, I'll just I'll flash a clip on the screen so you don't have to try and imagine what I'm talking about. But if you don't do something to hold that band in place, it's going to displace further back into the case and you will not have access to it. So when you go to reinstall your servo, if you're not aware of this, you're going to be driving and everything's going to be great until you shift into overdrive, and then it's going to feel like you're in neutral. Your RPMs will shoot way up to 5,000 or whatever, and you're going to be like, what the hell? Why do I have no fourth gear all of a sudden? Well, it's because the band displaced into the back of the case or deeper into the case, and you did not re-engage it because you did not have a tool such as this to reposition it once you took the servo out. So essential for these transmissions. I don't know how common knowledge it is or not, especially amongst the DIY community. Builders obviously know it, but the DIY community, that's kind of what my videos are primarily geared toward. It is something that you'll want to know if you get into the AOD family of transmissions. So it applies to all of them, not just the AOD. Alright, so this tool is used as an aid, I'll call it a compression aid, to install the servo pistons themselves. So basically what I do is I'll position this right over the center of the servo. I'll have my snap ring either underneath of it or already in position, and then as I put all my weight down on this and I press it, forcing the servo into the bore past the snap ring groove, I'll then use a screwdriver or a set of snap ring pliers to install the snap ring into the groove, and then I'll just simply take this off and I'm done. For the overdrive servo, especially for the the 4R70s, the diameter of those is a little bit smaller than the AODs. This literally allows me to install that servo piston in roughly 5 to 10 seconds. So you just take the snap ring, which is small enough such that this will actually cover all of it other than the engagement locations. You have your snap ring pliers engaged on the snap ring, and then you just press this down, stabilizing the snap ring with the pliers until you're past the servo snap ring groove, and that snap ring will literally snap right into the groove and you'll be done. Alright, this next tool, this is called a servo piston selection tool. The number is OTC T80L77030-A. So this tool I would say this is not, strictly speaking, essential or critical unless you're doing a case swap. All right, so let me explain how it works, and you'll understand once I'm done, and I'll of course flash footage so again you don't have to imagine. But how it works is you will install your low reverse piston assembly into the bore with the return spring, the big spring. Okay, you will not install the cover, leave the cover out. Then you will situate this tool. All right, you'll undo the nut here that will allow you to position this half of the engagement flange, if you will. Okay, this will engage into the snap ring groove, and then once it's engaged nice and tight, okay, you're going to lock it down. The next thing you're going to do is position a dial indicator with the plunger right over sitting on the top of the piston, and then from there you're going to crank down on the forcing screw with a torque wrench until you hit, I believe it's 50 inch-pounds, 50 or 55 inch-pounds. Then you're going to zero your dial indicator. So the dial indicator plunger is sitting right on top of that piston. The piston's all the way into the bore. It cannot go in any further. And basically this thing is holding it tight. So the next thing you're going to do is take either your torque wrench or a ratchet and socket, and you're going to start turning this counterclockwise. And as you're doing so, you're going to watch the dial indicator. Then once the top of the piston is up against the bottom of this tool and it's not going to travel any further, you record the total amount of travel that piston executed from its base or lowest position inboard of the bore to where it met the top of the tool. Then you're going to compare that to a chart in the ATSG manual, which will tell you, based on that measurement, which selective low reverse apply piston that you need to install into this case, this particular transmission, so that it is of optimal, or provides optimal band clearance. So there's 3 pistons available, and this is true for the AOD, 470, 75, all the same in this regard. There's 3 pistons. There is a short piston, or piston with the shortest servo pin, an intermediate piston, the pin is in the middle of the road in terms of length, and then there is a longer pin, which is the longest. And you can tell which version you have simply by looking at the base of the pin and counting the number of grooves. The longest pins have 3 grooves, the pins in the middle have 2 grooves, and the shortest pins have 1 groove. So it'll give you a range of measurements that correspond to each one of those 3 selective servos, and based on your measurement that you used by using this tool and the dial indicator, that will tell you which piston that case and that particular planet and band need to have installed to achieve factory specified band clearance, I should say. All right, so I know it's kind of a long-winded explanation of how that tool works. The reason I say that this is not, strictly speaking, essential is because if you're not doing a case swap and you're just simply reinstalling a new version of the same servo you took out, and you're not replacing the planet and you're installing a new band, you're not going to have enough of a variance there. There's not enough tolerance stacking, at least in my experience, to make a difference. I mean, there's 97 to 99% chance you'll be in spec. Where you can be out of spec, kind of where there's a lot of area of uncertainty, is when you do a case swap. If the case is deemed to be no good, you have to buy another case and shove all your, rebuilt internals into the new case. Then there is a chance that you may need to use a different piston, and you won't know that unless you have either this tool or some equivalent to it. All right, these are available on eBay. I want to say that one was something like 120 bucks. Kind of expensive, but again, if you plan on doing AODs to any extent, it's worth having. It just, specialized tools reduce the risk of assembly. They reduce procedural risk, and they make the work a lot more efficient. So the more efficient the work is, the less complexity, and the less chance that you'll screw something up, break something, damage something, or misassemble something. Therefore, the less risk you have when it comes to the overall project. So that's what really tooling is about. It's about de-risking your project or your build. And so dealerships and shops and whatever scale, large reman companies. I mean, the reason why they invest so much capital into tooling is so that they can achieve an economy of scale when it comes to production. Right? They want to keep all those variable production costs, those prime costs, and direct labor and materials down. So while tooling has nothing really to do with direct materials, it has everything to do with direct labor, making the labor portion of that cost driver more efficient and hence lower relative to earnings. Okay, the next set of tools that I'm going to talk about are these lip seal tools. So you have two sets of tools here, okay? Two sets of lip seal installation tools or lip seal protectors. On the left we have aftermarket tools, and then on the right we have the OTC tools. So here's my recommendation when it comes to these two sets of tools in terms of which ones to buy. If you're only going to do one of these transmissions or maybe a small handful, the aftermarket tools are fine. The lip seal aftermarket blue ones. I think I have 10 or 11 AODs or AOD-Es, excuse me, on this particular set. All right, this is the third set I've owned. Over time, after you cycle through maybe 8, 9, 10 transmissions, what'll start to happen is the lip sealing area here, as you can see on this one, okay, they get damaged. It's inevitable. All right, there's almost nothing you can do about it. I mean, maybe I'm not overly careful. Maybe some of you are a lot more careful and more dexterous than I would be or that I am. So you may get more miles and more units out of these things before they have to be tossed. But generally speaking, they're good for about between 6 and 10 units, and then after that you start to see wear in the installation surface itself. Like, this is an extreme case. I think this may have fallen on the ground a few times, but I will say that the OTC tools are a lot more durable. I mean, you can get 100 units out of these things, I would guess, before you have to swap them out, replace them. Okay, so the aftermarket stuff is available on eBay, on Amazon, on the net, elsewhere. This tool I bought off eBay. I believe Freedom Racing also sells it. They also sell bushing driver kits, test plates, which we'll cover in a minute, this gauge bar, which we'll again cover in a little bit, as well as a whole variety of different specialized tools for various applications. One downside with Freedom Racing is that they are expensive, but the upside is that they sell quality stuff. It's either the OEM dealerships, either OTC, SPX, Kenmore, Rotunda, all the same tools that the dealerships themselves use, or quality aftermarket tools that are very, very well made, like, for example, the tools from Adaptacase. All right, so let's talk about the OEM tools. So this is going to be the install tool set for the reverse input drum. We have the inner seal, and then we have the outer seal. So the number here for the outer is going to be OTC 307424. I don't know if you could see that. It's very, very tiny lettering. And then the inner tool ID number is going to be OTC 307425. So again, I'm sorry if you can't see that. I mean, those letters and numbers are really small. I don't wear glasses. I could see them, but I don't know if the camera's picking them up. Okay, so this is going to be for your forward outer perimeter seal. This is going to be OTC 307-423. And then for your intermediate clutch, this will service the whole piston, outer and inner. It's going to be OTC T95L-77005-A. And this makes quick work of the install there for that piston. So these tools I would consider to be essential. If you're going to rebuild one of these units, you have to have them. They make the job a lot more efficient, and I will argue that you almost can't do it. I would say you probably, reasonably speaking here, you can't really do this job without these tools. I mean, you can try to heat the lip seals and the square cut seals for the reverse input piston in transmission fluid to make them a little bit more malleable, make them easier to work with. But it's still going to be a bear if all you have is a traditional lip seal installation tool. So the reverse input specifically is, it's can be a nightmare. I've broken my share of those stupid sealing rings because I tried to force the issue, or I've tried to, get them to go in, and I just got impatient and I didn't either use enough assembly lube or I just didn't have the tool. And so, learn from those kinds of mistakes before you make them yourself. And if you're going to work on these units, acquire these tools. Now, these the pricing for these is variable. It just depends on what's available on eBay, who's selling it. This set here was purchased as one auction, and it cost me like $60 or $65. I normally see just one of these things go for that amount of money. So you may have to do some searching. You may have to be a little patient. Willing to wait for the right deal. But if you hold out, you might find any one of these tools at a very good price on eBay. All right, now I'm going to shift a little bit again, and we'll speak about the gauge bar that you see in front of you along with the depth micrometer. Okay, so I don't know what the tool number for this is. It has one. I don't have it offhand, and for whatever reason I can't find it anywhere here on the tool itself. But this is a gauge bar, and this is used in conjunction with a depth micrometer to measure for your intermediate clutch clearance, as well as to determine what selective pump washer you need to set and adjust your end play to within specification. So this is an essential tool. You need this or something exactly like it. This is the OTC tool. Like I said, I don't know why I don't have the number written anywhere, or it's not engraved that I can see, but I'll annotate the video with it. But if you want to try and replicate this tool yourself and you have the equipment to do it, here are the dimensions. So the whole thing itself, the bar is 9 inches long by 700 thousandths, both height and depth. So 9 by 700 thou by 700 thou. And then the distances from the edge here to the center of each of these holes is going to be as follows. And I labeled them A, B, and C, although you probably can't read the black Sharpie writing. But this first hole, hole A, is 1.387 inches from the left edge. Okay, the center of hole A. Hole B is going to be 3 387 thousandths of an inch inboard. And then hole C is going to be 4.517 inches. And let me see if I can measure the diameter of the hole itself, and they're all the same. I don't know if you can see that or if it's out of focus or not, but looks like we're sitting at 2 75 thousandths of an inch, so 0.275. If you don't have this tool, you're going to be at a serious disadvantage validating that you have the right clearance in the intermediate clutch and you have the right selective thrust washer installed on the back of the pump. Now, again, if you're in a jam and you haven't replaced anything hard part wise, especially things like the pump, the either reverse input drum or forward clutch drum, or the case, then you may be able to just simply reinstall everything and run with what you have. Now, from an intermediate clutch clearance perspective, at least all the units that I have done, it's not very many, I admit, I could stand to do more of these transmissions, I guess depending on how much of a glutton for punishment I am. All the ones that I have done had a number 2 selective flat steel in the intermediate clutch. Okay, it seems to be the most common. And there's 3 of them. There's a number 1, a number 2, and a number 3. And the number 2 is in the middle of the road in terms of its thickness. Number 1's thinnest, number 3's the thickest. And I have not seen a 1 or a 3. So more than likely, you're going to get a transmission, whether it be yours or somebody else's, and it's going to have a number 2 selective flat steel in the intermediate. And it's the first steel that you'll see when you take the pump out. So if everything goes back together, there's no hard part damage, you're just doing a soft part rebuild, especially no hard parts like the case, the pump, or the 2 front drums, then you should be okay without validating a measurement. If you don't have this gauge bar and or depth micrometer. As far as the selective goes, again, this comes back to always checking and assessing front end play before you do any disassembly. If you go to do that, you kind of, even if you don't even record the value, you just get a sense for how much end play it has. Like this one was, I want to say 15 to 20 thousandths or so when it came, before I took it apart. The transmission featured in the rebuild series on my channel, that is the AOD. It felt exactly the same when I put everything back in, including the original pump thrust washer. So again, same kind of deal. You want to balance risk versus time when it comes to maybe not having access to these tools. Do you wait until you can get the tool, or do you just run with it? And if you did a check on the end play, even if you just did a hasty check, a hasty measurement, and the end play feels exactly the same, then you're fine. You're not going to have any problems. But if it's dramatically different, then you'd have to question as to whether or not you misassembled something. If it's different, but it still feels like you didn't, everything's in the case as it should be, but you replaced the pump, you replaced the case, you replaced other parts that, would influence front end play, then, you're going to have to, find that gauge bar and go through the measurement process. So all that stuff I cover in the rebuild series, every single check you have to do for clutch clearance, for end play, for servo travel, it's all in there. So if you're curious and you want to see it end to end, you can check out those videos. Alright, I want to talk about the test plates next. And there is some discussion, some, I guess, I don't want to say controversy, but there's a couple of different schools of thought in our industry as to whether or not these test plates are worth having. Now, I'm firmly in the school of thought that states that they are essential, that they are a valuable tool that provides a return on investment well in excess of the cost itself. And I know that because there's been several times where these things have saved my butt on a rebuild, where I went to do a case air check using plate on whatever transmission, and I discovered a problem with assembly. Some sealing ring got cut or something got broke, and there was a no apply situation, or the apply was so weak I knew immediately that it was not just a product of my shitty air nozzle or something else that's otherwise harmless. So for me, what little money they cost, I think each of these plates can go from anywhere from $40 up to $150. It's still a minor amount of money, especially if it's a transmission that I see and do a lot of. I mean, it pays for itself in, one job, right? So this is the AOD version. And the tool number for the plate is going to be OTC T82L706-A. So that's OTC T82L7006-A. I omitted a 0, so my bad. This is a solid steel plate. It's fairly heavy. I guess it's an 1/8 of an inch thick, maybe a quarter. Yeah. 150 thousandths thick. This is very, very, very effective. So I would never rebuild an AOD without this plate. The very first AOD job I took in, as soon as I knew I was going to get it, I bought this plate, those lip seal tools. The bushing drivers I didn't buy right away. I fortunately was able to install the bushings because of other drivers I had, but once I realized I was going to be doing these transmissions, I just bought the bushing driver set and then that rear case bushing and then all these other tools that you see. So this is the AOD-E version, AOD 470W. This is aluminum. It's made by a company called Answermatic. I've never heard of them. This is the only such plate that I have that they make, but it's also a good plate. I mean, it does what it's supposed to do. So my recommendation, especially if you're thinking about getting into the industry and either starting your own shop or you're joining an outfit that requires you to have your own tools with you, I would definitely recommend investing in test plates. Okay, I covered all the tools, so I'll spend just a couple of minutes at the end here to discuss reference materials. So for all transmissions that I build, and I would strongly recommend you do the same, is to acquire the ATSG manual. So I believe I still have the link to the PDF that's available online for the Ford AOD transmission. This is the ATSG manual. It's pretty much a must-have. I would not recommend, especially if you're a first-timer DIY, I would definitely not recommend you buy you rebuild a transmission without, at minimum, having the ATSG manual, on the bench. Okay, the next book I have here is by George Reed, Ford AOD Transmissions. I have several of these Workbench How-To series books on transmissions and engines, and I like them because they're full-color pictures, and while the level of detail isn't super fine, they kind of give you all of the information that you need to know, and at the same time, the pictures are nice and sharp and clear, minimal ambiguity or confusion. If you're looking for really, really granular information in these about one aspect or another, when it comes to a specific transmission, that's going to be where your ATSG manual provides you that kind of information. But these are good for any kind of tips and tricks for modifying or building a transmission for performance. And he walks you through both the AOD as well as the AOD 470W, and he also discusses swapping 470 parts into the AODs a little bit. So good material to have. Another reference I'll cite that's out there on the net, and I'll put the PDF link in the description too, is Silver Fox Transmissions. And so Silver Fox Transmissions is owned by Dan Gilsdorf. He's a performance AOD 470-75 guru. He sells parts on his website, and he also builds them. To what extent he's active on forums and other places, I don't know, but he does have a PDF that kind of walks you through all manner of different tips and tricks and pointers for rebuilding AODs. Everything from approaching clutch clearances and setting up your end play to different lube modifications and building AODs for performance, addressing areas of weakness, and I want to say it's like a 12 or 15 page PDF file, but it's definitely worth having at your fingertips if you're new to these transmissions. So those three things, as far as reference material plus all these tools, that should get you squared away and ready to build an AOD 470-75W AOD-E transmission, so that you can be sure that your build will be successful. If you have any questions, comments, go ahead and leave them below. If there's anything else that you want me to talk about when it comes to these transmissions, AOD, AOD, 470-75W, leave it in the comments there as well, and I will get to it as soon as I can. Otherwise, thank you so much for watching. Enjoy the rest of your day or evening, and I look forward to seeing you on the next video.